Ph.D. in Computer Science and Engineering from Anna University. Research interests include parallel and distributed computing, peer-to-peer computing, grid computing, cloud computing, and big data analytics. She has experience as a professor and head at Loyola ICA College of Engineering and Technology, Department of Information Technology. And she also been an assistant professor at Department of Computer Science and Engineering at Sri Venkateshwara College of Engineering, Chennai. And also, she has experience as a teaching research associate in the Department of Computer Science, Anna University, Chennai. And also, she has been an assistant professor at the Department of Information Technology, SSM College of Engineering, Chennai. She has published about 30 papers in the international and national journals and conferences. She is a life member of ISTE. She is a reviewer for Computer and Electrical Engineering Journal and Future Generation Computer Science Journal. She had been the resource person for the workshop on digital classroom, big data analytics using Hadoop, machine learning, deep learning, cognitive computing, software testing, blockchain technologies, cyber security, and cyber forensics. Ma'am, the session is yours, ma'am. Kindly carry on, ma'am. Thank you.
Thank you, Professor Dr. B. U. Anubharati, ma'am, for the introduction.
Yes, ma'am.
For the introduction, and we are going to have a 5 days FDP on big data analytics. In short, you have given us big data adoption and cloud deployments. Right, it's great to be connected with you today, and we are going to explore about different components. Are all able to hear me? You can give a thumbs up on the chat or on the reaction if you're able to hear me. Yes, thank you, Meghla ma'am. Yes, some of you have given your answers. Yes, thumbs up. So, I know most of us, we are connected and you had a day of your college, right? And most of you are tired. Yes, most of you are tired.
Recording in progress.
Okay, most of you are tired and still you have come out of comfort zones to learn something new about big data analytics. Okay, so here on to this 5 days, I will tell you, share what are the topics that we are going to see step by step. And how many of you have worked on Hadoop? If yes, type yes on the chat. No, type no on the chat. Because to start with my session, I need to know what kind of basics you all know. Some of you said no, Lohit sir says no, Harini ma'am says no. Okay, others? Have you worked in Hadoop or you haven't worked? Shobana ma'am says no. Others? We have like around 25 plus participants. If you all give me an answer, it'll be easy for me to schedule it. How you go on? Most of you are new to Hadoop. All right, so we'll start from the basics and we'll go. Thank you, Tarani ma'am. We'll go by step. Okay, so the learning is what we know about it and how we are going to explore it. And I'll be showing you the demo of Hadoop, how it has been installed. All right, the demo section will be shown to you. All right, and you can start. Since it is new for you, some of the words that I use may be different, but eventually as we progress by one, you'll be able to understand more about it. You'll be able to understand more about it. So let me share my screen. Okay. Are you all able to see? Just give me a minute. Okay. If you're able to see the screen, just can you put it onto the chat? Yes, visible, Lohit sir. Yes, thank you. Thank you for answering, because you know it is very difficult during yes sir. Okay, so during the session, so most of you are able to see my screen, the brochure of this event. Yes, thank you. Thank you. So today, this is a 5 days FTP on big data adoption and analytics of cloud platform. So from Monday, we are starting from Monday until Friday. You'll be seeing every day 1 hour till 7 p.m. What are the topics that you're going to see? All right. So what are the content of this FTP? Because it is 5 days. If you take big data, it's totally a huge topic to be considered. All right. In short, we are going to see what are the topics that we are going to see for this 5 days. All right. And first, we are going to see about Hadoop. How is Hadoop? What is Hadoop distributed file system? And in which, how are we going to work with MapReduce program? Okay, today we are going to focus on Hadoop and MapReduce. All right, what is MapReduce? Have you ever heard about MapReduce, or is it new for you? MapReduce. It's new. Thank you, Harshini ma'am. If it is new, type new Lohit said, so it's all new. So learning the concepts is more important, and once you know the concepts only, you'll be able to start programming and working on towards it. So for most of you, full topics are new. Okay, we'll go step by step. And then what are the commands that are available in Hadoop distributed file system? Okay, once you set up Hadoop, you have something called as distributed file system, where it stands for, if you're taking notes, you can make a note of it. It stands for HDFS, which stands for Hadoop Distributed File System. All right, in Hadoop Distributed File System, what are the different commands that how are we able to view it, your files that are loaded onto your Hadoop system? All right, and the most thing you use Facebook, you use YouTube, you use so many applications where a huge volume of data are being progressed, but predominantly it uses MapReduce and job scheduling. All right. So HDFS I told, and we'll be seeing eventually in the following days about HDFS and Yarn. Okay, the schedulers. Then we will be seeing working with Pig and Hive, how we'll be using Pig, how to write Pig scripts, okay, scripts using Pig language, and Hive, how data you take in Amazon, how the data are processed using Hive. A sample applications of Hive also will be considered. Okay, so listen, and also NoSQL, it stands for not only SQL. HDFS means not HTTPS, HDFS, Hadoop Distributed File System. Hadoop Distributed File. So today we'll see about the introduction of Hadoop, some of the demos. All right. Okay. So thank you for asking. Whenever you have a doubt, you feel free to ask me. And then how can you work on visualization using Tableau too? I suppose some of you have you worked with Tableau, or even that is new. That comes into the 5th day. When we come to the 5th day, we'll discover more about it. Okay. Okay. So these 5 days, 5 hours, we are going to discuss about this. I tried to maximize and fit, and the way you step into the workshop or the FTP, the way you step out, you will be capturing content of what has been given. So coming into what is FTP, sorry, what is big data? Okay, big data, the word itself, it shows, right? The word itself, it shows big data. All right. So big data, it refers to huge volume of data that cannot be stored, processed using traditional methods, or traditional approaches within the time frame. So sometimes you think, what is the biggest size of data that you know? Answers on chat. Do you want to have an active session or you want to have a passive session? What is the maximum size that you think that could be big data? KB, kilobytes, megabytes, gigabytes, or terabytes? What is that you think that could be the big data? Terabytes, thank you. Zettabytes, thank you. Then terabytes, megabytes. So each of us, what are the highest size of bytes that we know, we try to say. Here, see, the entire thing is going to be erased from your mind, and how big data analytics work. Listen to this word very carefully. Yes, it belongs to huge volume of data. There's no doubt onto that. But more importantly, the way in which it cannot be stored or it cannot be processed. Okay, it cannot be stored or it cannot be processed. How many of you use Gmail? How many of you use Gmail? Do you use Gmail? Yes. Okay. In Gmail, do you use your Google Drive? Do you use Google Drive? Can one of you give me the answer? What is the maximum size that a Google Drive could accommodate? That a Google Drive could accommodate? 15 GB. Yes, 15 GB is the maximum size. Say for example, for I don't know, if you are working, somebody, your GB has 15 GB has been completed in your Google Drive, and then we go in for another mail ID. Yes. See, if you think 15 GB, is it a big data? Okay, we can't say that could be a big data, right? But when you think, okay, no, it's not, you think it's not a big data, but for in Google Meet, for a Google Drive to process, even if you have got 15.01 GB, if you have got 15.01 GB also, whether your Google Drive is going to support it, you have completed a 15 GB? No, yes. So listen carefully. Big data, it means huge volume of data. It is not always the size of the data. If you are not able to, listen carefully, if you are not able to process the size of data. See, 15 GB, some said, like Sai sir said, it's very small data. But for your Google Drive to process it, for your Google Drive to process it, it is a date. Able to understand? For your Google Drive to process it, only 15 GB is the maximum size of data. So you should never think it is not the size of data that defines big data. If your system, say for example, you have got like some of you, the mobile has got 128 GB. If you have got 128.01 GB also, your mobile cannot process it furthermore, right? So for that, it is associated with what are the applications that you use with. For Google Drive to use, you think as normally, if you think 15 GB is a small data, but for Google Drive, 15 GB is a 15.01 GB is a big data. So okay, you were able to understand it is not the size of data. Data is neither gigabytes, terabytes, petabytes, exabytes, or anything. This does not define that as big data completely. What is the size of attachment that you can keep it onto your email? If the size is more, it goes for a Google Drive. If the size of Google Drive exceeds, you'll not be able to use it. It is not the size of data. If you are not able to process the kind of data onto a particular application, for example, 15.01 GB is a big data for Google Drive. It is not the size of data. If your application is not able to process it, then that size of data is called as to be big data. Okay, is it clear or is it confusing? It is not the size of data. If your application is not able to process that size, for then you define the data to be as big data. It is always, some of us, you focus only on the size of data. Do not focus on the size of data, the size of data and its associated application. I repeat it, the size of data and its associated application. Okay, so that defines, and that could be petabytes, exabytes, or whatever it is. If you've got a pen drive, if you have got a 64 GB pen drive, you cannot have more onto it, right? So those kind of applications, okay, Mahesh sir, is it clear now? Your data that is associated with your application, that is how we can define the size to be as big data. Is it clear for others? You can give your answers on chat. It is not, thank you. It is not the size of data. The data and its associated application defines it is going to be big data or not. So, how many of you use Facebook, right? We all use Facebook. So, per day, see, Facebook is generating 4 new petabytes of data. Imagine how big volume of data it will be. How Facebook is going to process it. So we need to understand it's a huge volume of data and how they are processing it. And Facebook, now you can see 4 billion hours of daily video for per hour. Per day, 4 billion hours of videos are being watched through Facebook. And users generate 4 million likes every minute. 4 billion of video that people watch. Okay, when people watch the video, Facebook, so many people watch. So many of them have real accounts, so many of them have got fake accounts. When they are seeing the video, you need to see it streamingly without any disturbance. Okay, for which imagine how much huge volume of data Facebook is processing. And user generates, you see, you just think, yeah, I'm just giving a click or like or something like that. User per minute 4 million likes. How many minutes per day? Per minute 4. These are the data and it's to be processed. See, 2,43,055 new photos are uploaded every minute on the Facebook. See how huge volume is the data. We only think only about our Facebook accounts. There are 127 photos uploaded on average per user, per Facebook users. On an average they've taken. All right. Can you visualize? Yeah, petabytes. It's the level of data. Okay, you can check it out. Okay, so if you could find, are you able to visualize how huge is the volume of this data? So here comes your big data analytics. When you take, I don't, how many of you search using Google? How many of you searched today using Google? That's a nice one. Yes, me. Thank you, Mahesh sir. Every day. Yes. Yes, I am. Okay. Every day we use, right? You think only we are using, for us, everything is Google, right? Everything is Google nowadays. Only what Google says we do. Every second, 1 second, okay, 63,000 search queries have been generated. For every queries, are you getting your answers immediately? Yes, always. Thank you. Every day. Yes, we are getting. If any doubt, there is only Google. Any doubt, it's only Google, right? See, and also it uses Google Translates 5.6 billion searches per day and 2 trillion global searches per year. Imagine this is a huge volume of data they are processing. Facebook, okay, Google, they are the ones they use these big data analytics and large. How many of you use Twitter? I don't know how many is Google Assistant. Yes, Twitter. Every second, 6,000 tweets are there. So 3,50,000 tweets are sent per minute. Okay, 500 million tweets per day and 200 billion tweets per year. Okay, most of them we use Twitter, right? Twitter, we use Facebook. See, can you imagine how we think of a smaller section? How are we going to use this data? But see how these reputed organizations wherein they have a huge volume of data and they are processing it. All right. So coming now into YouTube. Okay, who uses YouTube? 2 billion users are using YouTube every minute. For every 60 seconds, YouTube is uploading 500 hours of fresh videos are uploaded to YouTube. Imagine how could be the size of the data. All right, how they'll be. How many of you have got a YouTube channel? Yes, have you got a YouTube channel or you use YouTube? Almost 5 billion, almost 5 billion. For every single doubt, go to see YouTube video. Okay, thank you, sir. Others. So almost 5 billion videos are viewed on YouTube every second. See how huge is the service they are rendering. What is the huge service they are rendering? All right. So we have seen about Facebook, how it works. Google, how it works, Twitter and YouTube. See, I've taken these 4 examples. Okay, we have taken these 4 examples. How huge is the volume of data and how they are working. LinkedIn, how many of you there in LinkedIn? LinkedIn, Google Plus receives, yes, most of you are there on all the social networking. This pandemic has pushed us into this, right? So LinkedIn and Google Plus, they receive tens of terabytes of data on daily basis. Okay, on daily basis. So how much of volume of data is being stored and processed onto this data? Can you imagine how this works? Do you have any idea how do they store? Is Instagram? Yes, sir. How do they store? How do they process? And every time when you type Gmail username and password, we just want to see our inbox immediately, right? Are you getting it every time? How much process is being done at the backside? Facebook, you click a like, you want to like and you want to see it. You click a video, it should be uploaded automatically. Okay, when you go to YouTube, you definitely want to see a video without any buffer delay. Yes, so as computer professionals, our focus is how these huge volumes of data are being used, how huge volumes of data are being processed. That is our focus today. Okay, so number of users are increasing, storing and processing is becoming a very challenging task. Data holds lots of valuable information and it should be processed in a very short span of time. By using this, you can boost whatever. So traditional approaches will not be able to use it. So to process all these huge volume of data, the one best solution is Hadoop. Okay, there is where Hadoop comes into existence. So now you are able to understand. You have seen the air traffic control. So many data across the latitude and longitude, how it is progressing. When you travel on flights, you can see every move of it. Okay, the flights, even right now, you can see how the flight is moving on different flights. Huge volume of data have been transferred and they monitor the progress of the flight on real-time basis. Huge volumes of data are being exchanged through the cloud service. All right, for all these kind of application, the only solution people use is called as Hadoop system. All right, able to understand till now? Are you able to imagine or visualize the size of data?
Whenever you use a Google product.
Okay, yes. So, yes. So here now you are able to visualize how huge is the volume of data. See, I told you we all use Gmail. When you go into Gmail, you see, click on the night dots, you see Google Photos, Google Slides, Google Docs, Google Sheets, YouTube. So many applications are bundled inside YouTube. Now, I'm going to take you to a video in sitting in different places. I don't know, wherever you are there. Listen to the video carefully. At the end of it, I'll be asking some questions you're going to answer. So this is how data is being stored on Google. That is called as Google's data center. Okay, Google's data center. Okay, you can see, listen to the top.
Whenever you use a Google product, you're
Yes.
connecting to one of our data centers around the world. Let's take a look inside and see how they work.
See how the data are stored in Google.
Google employees work here, keeping the data center up and running 24 hours a day.
This is how the Google data center looks.
The networking room is the first stop on our data center floor. The equipment here routes requests to the right servers in the next room.
So this is the
These
networking
computers
room.
also allow our data centers to communicate with one another globally.
Different data centers, they are getting
On the
communicated.
server floor, powerful computers handle everything from billions of searches to posting YouTube videos and protecting your email against viruses. We've custom designed these servers to be compact and energy efficient. To ensure you have access to your data whenever you need it, we keep each piece of data stored on at least 2 servers.
So it's stored in 2
We store
servers.
another copy of the most important data on digital tapes. When a hard drive breaks, we erase all of its content.
So for
Then, for
data
extra security, we destroy it. Disk crusher. The machines in our data centers are always working. Cooling towers like these pipe in water to cool them down and keep them running. When the water heats up, pump it back outside or it evaporates. Now that you've had a glimpse, walk inside yourself. Explore a Google data center with Street View.
Okay. What did you understand from this? See, what was there onto the first floor? Can I give the answers on chat, or you can unmute if you're so? Yeah. First, networking. Thank you, Lohit sir. Very well answered. On the second, you have seen second floor, they were telling about custom designed servers, right? That is where your data are stored. Okay, first is networking, and they connect between different data centers to store data. Very big rooms are there, but each of the servers they have given, right? The servers you can see, you would have been seeing a rack being pushed out into it. They are custom designed servers which was reduced in size and process huge volume of data, and it process, and every time, yeah, to store very big different data centers. Totally, we have Google has 21 data centers around the world. Suppose one data center fails, you don't know, you get your data from the next server. All right, that is what is being duplicated. Onto the third floor, you have got your tape libraries. If your hard disk fails, they crush it. Okay, they're showing how they are storing the data with very less space. Okay, and those data centers on whatever the servers they are customizing it, they use Hadoop distributed file systems. All right, they use Hadoop systems are being used. Do they use an AC? Even for a small room, maybe use AC, right? Do they use AC there? What did you understand from? No, they aren't using AC. They have been using water that had been circulated using cooling towers. They uses cooling towers to do it. Thank you, Nitya ma'am and Shobna ma'am. You have listened to it very carefully. Okay, so that they say they are big. There are 3 V's or more V's. Okay, I don't know how many V's it keeps coming out. All right, but the major 3, you can see the volume of data, the velocity of data, and variety of data. And when you take Hadoop system, you can work with structured data, unstructured data, and semi-structured data. Okay, when you are going to use a database like SQL, you have got structured data. If you're going for an unstructured data like Facebook post or Twitter tweets, it's totally unstructured data. Semi-structured data, it is little structured and unstructured. Okay, so all these structured, semi-structured, structured data, text, a video, a audio, a JPEG, a PNG, all kinds of data, all varieties of data could be processed in big data. All right, and then the velocity of data, right? It's unpredicted speed. Okay, if you're using an RFID tags or sensors or banking transactions, so many applications they use Hadoop. All right, volume, I told you, right, how huge is the volume. I think you should have visualized it. How much is the size of YouTube, the Google, the LinkedIn, the Facebook, right? For every minute, how they're processing it. But we don't know anything, just we are just utilizing its functionality alone. Okay, I told Facebook the huge volume of data, for example, 4 new petabytes of data per day. Velocity. Okay, companies like Facebook and Google, they analyze bigger data sets every day. They are doing a data processing, and varieties of data, whatever could be the type of data. Now we have seen, able to understand. Yes, IBM. Yes, sir. You are able to understand till now what we have seen. What is about big data analytics, how companies are using it, as you have seen about the Google's data center. Now let me take you into the Facebook's data center. Listen and tell me which one is better. All right, okay, at the end of it I'll be asking a question, you will be able to answer it.
What happens when you upload a baby picture to Facebook anyway? Well, it goes from your computer through a bunch of wires out of your city and travels at nearly the speed of light until it gets here. This is Facebook's first data center, located in Prineville, Oregon. To call it massive is an understatement. It's got buildings big enough to fit 4 football fields in, and all of it so that you can view that Throwback Thursday photo whenever you want. So Facebook has 6 data centers around the world, all but 2 of which are in the United States. This one was the first, and it's quite a sight. Many of the technologies inside were invented by Facebook. One example is air cooling. Oregon's nice and cool, and Facebook realized that it can take air from the outside, mix it with water and computer exhaust, and find a way to cool its computers without needing to use energy-sucking air conditioners. Why cold air? Well, computers can't run too hot or they just don't work right. They also can't run too cool or they have the same problem. Behind all those blinking lights, that's Facebook. So is this, and this, and this. How much of Facebook is stored here? Well, all of it. If Facebook's other 5 data centers were suddenly to stop working, you could still rewatch your old Ice Bucket Challenge video, and Facebook hopes you won't even be able to tell anything was wrong. By the way, there are exactly 10 people on staff who fix computers all day long. Facebook is experimenting with testing apps on a bunch of different phones, even old ones dating back as far as 2011. The last little nugget, a computer that can learn to paint. This is a computer program analyzing thousands of paintings and then using that information to paint one of its own.
Okay, so is the video stucking? Is it okay? Okay, how large is this biggest data center of Facebook? What is the, yes, Facebook data center is better. What is the size? Can one of you say, you can unmute and say, or can you say what is the size of the data? Sorry, size of the Facebook that I showed you now? Unlimited, no. They gave, I give you a hint. They told you about a football ground size. How many football grounds? 4 football grounds. Did you listen? Yes, 4 football grounds. Is this, you know how huge is one football ground? And they use 4 football grounds is the total size of the data. Totally, see how huge is the size of data, how huge is the data center. How many people are working on it? How many people are working inside this? 4 football grounds. Whether anybody listen to that onto the video? I want exact number. How many people are working on it? Anybody listen to it? Yes, it is exactly 10 members are working on to that. Roughly 10. Thank you, Mahesh sir. 10 people, 4 football grounds. Do they have an AC in Facebook data center? Yes, no? Yes, sir. No, they don't have. Even for a small room at home, we have data centers, we have air conditions. They don't. See how efficiently they are using the technology. And this Facebook is near a river data centers, especially Google's or Facebook, so that they have a cooling effect is more because lot of heat is getting dissipated. When you see, as I told, this total map reduce technology or map reduce methodology is invented, or I cannot say it is developed by Facebook. It's developed by Facebook. So you're able to visualize huge volume of data. How many data centers were available? Anybody listen to it totally? Onto this video, it was saying 6. Thank you, Lohit sir. Thank you, Harshini ma'am. 6 data centers. Okay, and we have seen 2 are very big, and one of them we have seen. Okay, if one data center is lost, mics on mute. Somebody's mic is on. Okay, I can unmute. Thank you. Host has unmuted everyone. So it is easy for us to. Okay, so now you are able to understand it. Okay, how huge volume of data, how it is getting processed. So Dong Cutting and Michael developed Hadoop for NUT search engine. Okay, this project was funded by Yahoo in the year 2005. And Yahoo gave the project to Apple Apache. So that project, okay, they developed Hadoop for a search engine called NUT. Okay, it's in 2005. And then that project is totally funded by Yahoo. And then in 2006, Yahoo has given it to Apache Software Foundations. So Hadoop is used in many large companies like Yahoo, Facebook, Twitter. I told you, right? So these are the things, these are the people they use. So I'll go into a new share. So you'll be able to find it out. So this is the website. wherein you will be able to find it out. You're able to see my web browser, Apache Hadoop. If you search, can you see this hadoop.apache.org? Are you able to see the web browser now? Yes, thank you, Meghala. Yeah, thank you, Lohit. So this is the, it's an open source Hadoop because people use this reliable, scalable, distributed systems. All right. And then it's a library, it's a framework for distributed processing of large data set across clusters using simple programming model. Please don't annotate. Somebody is trying to annotate. Okay. Okay. And it is designed from single servers. You can also set up single Hadoop node cluster or multi Hadoop node clusters. I've conducted workshops for students, faculties, because it takes a lot of time to set up a real Hadoop system, okay, a single node system or a multi node system, okay. And if you see here, and can you see downloads? So these are the related projects in Apache, like Ambari, Cassandra. It's a multi-master database. We'll be seeing about Hive. We won't see about HBase. I don't know. We will not have time about Pig. I told you it's a high-level data flow language. Okay, and it's very secure. Mahout is for scalable machine learning and data mining. HBase. Okay, Hive, it's a data warehouse for summarizing and ad hoc queries. We'll be seeing demos of Pig and Hive. And Spark, you know, it's very fast. General computer or using Hadoop data, extract, transform and load, machine learning, stream processing, and graph computation. Spark. And it's Zookeeper. So many things are there inside Hadoop. When you click on downloads, okay, when you click on downloads, see, I told about Facebook, yeah, YouTube, Google will all work in source. Okay, they will work in the source. But so the latest release is on June 15, 2021. But as we are beginners in starting, we need to work with the binary downloads. Okay, we need to work with the binary downloads. I've installed this only into my system and I'll be showing it to you. Okay. So you're able to understand from where you are able to get it. Okay. Now moving on to our okay. So this is how they've started working. This is the structure of Hadoop. So I told all your files are stored inside HDFS, which will be a different storage from your file, from your operating system and your hard disk you have. All right. So Hadoop distributed file system is the storage. Yarn is for resource management. We'll be seeing about Yarn, yet another resource negotiator. It stands for yet another resource. How does the resources see? If it is single node Hadoop cluster, you'll be able to do it. But if it is multi-node Hadoop cluster, different nodes, different where the data is and how the resources are allocated and how job scheduling and other things are done. So Yarn plays a vital role onto it. Okay. And then coming into, I told you, right, when you want to extract data, if it is structured data, you'll be using Scoop. Okay, if it is unstructured, we use Flume. The entire course we give it at CIRF. Okay, so but it takes a long time for you to learn, understand, because it's not like a software that you click, right click. You need to have an in-depth knowledge of installation of Hadoop. Okay, so as you are new to it, and it's okay that you're trying to understand a new technology. Okay, this is the base. Everything, when you want to use a system, you need a hard drive to store data stream. Once you set up Hadoop, HDFS is for storage. Yarn is for resource management. If it's single node Hadoop cluster, you have a name node and your data node. But here, when you have a multi-store, see Facebook, how many different servers, right? How many data have been split out. For that, they use for resource management and job scheduling. Yarn has been used. When you want to use a MapReduce, you have MapReduce processing different applications. If there is time, I'll show you on both on Java and Python. Spark is for data data flow engine, Hive and Drill. You have got different queries. We'll be seeing about Hive, Kafka and Storm for streaming applications, for streaming, right? When you want to develop a machine learning algorithm, you use Mahout, okay, and Smart MLib. If you're going to do a scripting, we use Pig. I'll show you an example of Pig scripting. HBase, no SQL. So not only SQL, it uses HBase. Oozy for scheduling, Slower for searching and indexing, and Zookeeper and Ambari. They are the one, they do the entire management. So when you want to learn, first you need to learn about HDFS, Yarn, move on to MapReduce, Hive, Mahout, Pig, HBase, and then learn about Spark, Kafka, Solar, Oozy. Then we go into a Zookeeper. This is the methodology. When you want, see, I told, right, if it is Facebook, LinkedIn, you have unstructured and semi-structured data. In order to directly extract data from Facebook or LinkedIn or Twitter, we use Flume to go load it into our HDFS. If it is a very structured data like Excel or databases, you can, MySQL, you can use your Scoop to extract your structured databases. This is the entire framework of Hadoop. Able to understand till now? Any doubts? This is just the structure of it, and we need to dig deep into each one of it. Thank you, Sai. What about others? Okay, you are able, it's clear. Okay, so mostly we'll have to focus on the understanding of the technology. Okay, Hadoop is open source. I told it's managed by Apache. I showed you the website also. You see, it is like an elephant, right? Whenever we think it is big, we think it's elephant. It's named, and this Long Cutting, who was there, who developed it, his son was playing around with a yellow stuffed elephant toy. So when he was developing this, okay, so that is why he has given the logo to be as this. This is the logo of Hadoop, okay, yellow stuffed toy elephant. So Hadoop is designed to store and process huge volume of data efficiently. That is what Facebook, YouTube, LinkedIn, Twitter, they are all using. So first, what was the basic components that you need to know? The basic or the major important components of Hadoop are two that we are going to see today, which is HDFS and MapReduce. Starting itself, I told how your data are stored onto Hadoop system is called as HDFS, Hadoop Distributed File System. Okay, I'll be explaining you the technology behind MapReduce. And the technology behind how MapReduce works. Okay, when you take HDFS, okay, it is used to store and manage the data. So when you use your operating system, okay, when you use our operating system also, we use operating system, and wherein we have different applications, but majorly we need to store your application onto your drive. Okay, we need to store your application onto your drive. So sorry. Okay, two components we are going to see in depth. Okay, HDFS, it's for storing and managing. Okay, and MapReduce is for processing and computing the data that is present within your HDFS. So for storing, we use HDFS. For processing and computing, we use MapReduce. Able to understand about these two components clearly? HDFS is for storing and managing. For processing and computation, it is MapReduce. Is it clear? For storing, it is HDFS. For processing and computation. So when you take Hadoop system, okay, I told you for storage, what do you use? HDFS. For processing and for data analytics job, you use MapReduce. Is it clear? For storage of your data sets, we use HDFS, right? For doing a data analytics application, all right, we use MapReduce. So when you take, listen carefully now, when you take data storage, okay, you have two components. One is a name node, the second is a secondary name node. Okay, so name node is a master node where you have your data, you have your data being stored. Suppose if the name node goes into a failure, then your secondary node comes. So this is a master. The data, that is HDFS, is your master. Okay, it's your master where all your data are stored. But I told you, when you want to work processing and computation, it is MapReduce. So here you have a job tracker. The job tracker, the slave is the data node. Okay, from the job tracker, it goes to a task tracker, and data are being stored into a data node. Okay, so master is your name node, slave is your data node. To do its data are stored into your name node and data node, and then your jobs have been processed using data node and task tracker, doing a job tracker and your task tracker. Okay, one thing we use is the storage of data, that is in your name node, that is a master, and the second is your slave. Okay, when you want to do an analytics, use MapReduce, where you have a mapper and reducer, and your job tracker and your task tracker. Okay, so this is how you can understand the Hadoop core components. I told two are the core components, HDFS and MapReduce. So when you take HDFS, it is your name node and your set of data nodes. When you take MapReduce engine, you have your job tracker. And then the task. So this orange color is your master and this is your slave. So from the name node, it has been splitted and stored into different data nodes, the data set. So this is the admin, this is the master, this is the slave. So from the job, it goes to different task tracker and it maps and gets converged to it. Okay, so master node, it consists of generally each Hadoop cluster, whether it's a single node Hadoop cluster or multi-node, you have a single master and different slaves, or multiple master and each and multiple master, different clusters of slaves you can have. So in the master node, you have your name node and job tracker. Name node belongs to your HDFS, job tracker belongs to your MapReduce component. In the slave node, you have data node, where data belongs to your HDFS and task tracker belongs to your MapReduce component. Is it clear? Name node and data node. Name node is the master node, data node is the slave node. Both comes under HDFS. Job tracker is under the master node, task tracker is on slave node. Both comes under MapReduce. Is it clear till now? Okay. Yes, thank you. So name node and data node. When I take name node and data node, name node and data node, that's the storage node. Job tracker and task tracker, it's the computation nodes. Okay, all these name node and job tracker can be configured onto a single machine. Task data node and task tracker can be configured into multi-node machine. For the demo for this 5 days workshop, I have set it up for the same system only. This entire system only, we have set it up the name node and the master and the slave single node Hadoop cluster we have done. And in my company, and that is CIRF, which stands for Computation Intelligence Research Foundation, you can find the website cirf.co.in. We have done single node Hadoop cluster and also multi-node Hadoop clusters, okay, according to the application. So secondary name node is a part of Hadoop cluster which comes under HDFS. So what are the two components? You're able to understand what are the two components, major components of Hadoop? One is HDFS and the second is MapReduce. And you have a master and slave. The master component of HDFS is name node. The slave component of HDFS is data node. And the master component of MapReduce is job tracker. And the slave component of MapReduce is task tracker. Is it clear? Is it clear till now? Yes, no? Okay. So you have two components, I repeat. One is a HDFS, where it have only storage of values, and the second is MapReduce, where you process and compute, and it works in the process of master and slave components. All right. So the master is your the master component of HDFS is a name node, and the slave component is a data node. Both the data node and name node constitutes your HDFS. When you come into your MapReduce component, the master component is your job tracker and the slave component is your task tracker. Both job tracker and task tracker, they combine to give you a data analytics job that is done using MapReduce component. All right. So here, these are the two components, because once you know the basics, you'll be able to understand how other things done. So I already told you it works on structured data, unstructured data. It brings valuable to unstructured data. So it is easily scalable. It's totally fault tolerant. That is what YouTube, when it's once one of the servers is breaking down, you are not able to find it. It replicates and you're getting this services being done. Same thing with Facebook and Gmail. Okay, the data stored in HDFS, but automatically it gets replicated in two other locations. Once I load even a small file, see, you should not think that drive is your local system. No, it's a different system. Okay, if even though I install a Hadoop into my system, the location is different. Okay, it's very fast at processing. That's what Facebook, Google, and YouTube, LinkedIn, Twitter, they all use it. Ecosystem is robust and very, very cost effective. Very, very cost effective. So once we have 5 more minutes, okay, I'll share. So once we install, you need to download it, right? As I told you, you need to download it from this website. Hadoop, the latest version is Hadoop 3.3.1. I've installed Hadoop. Okay, if I want to open, you're able to see my entire screen. Yes. So after installation itself is a different process. I'm not showing about that. Okay. Once it is installed, if I give localhost .9:9870, I told you about name node, right? I'll be able to see my name node. Once it's not a different thing like how you download and install other applications. The entire step itself is different. Okay. So can you see on Jan 3rd, 434, I reinstalled the new version of it. Right, I have used different versions. I can show you what are the different versions. And this is the name node. When I click data node, it's the slave. Okay, it's the slave part. Can you see? I have one data node. Okay, if there is a data volume failure, if it is a snapshot will be there. The startup progress, when did I start? All right, what are the save points that it has taken? And I told you about HDFS, you remember it? So when I come into utilities and I run, I see my file system. Just uploaded one file. Okay, I've just uploaded a file to show you a demo about MapReduce. Maybe we don't have much time today. Maybe following day, I've created an input. I've just created a small text file. Okay, and it's a small text file called file f1.txt. I've uploaded it to HDFS. This location is different from my existing location. Hello world, how are you? Hello world, how are you? Maybe tomorrow's class I can show you how it has been done. All right, how it has been done. Okay, and then how to create, I'll tell you. All right, so once I download it, can you see my terminal? Yeah, thank you. We have got 2 minutes to go. I'll try to show you. So this is where I've downloaded and uploaded the Hadoop file system. Okay, the latest version I told you, right? Hadoop hyphen 3.1. So this is how the file looks, and we need to work on with the files. Okay, inside the installation of the files. Okay, in installation of the files, we need to work on with that, and there are different library files available, and we have to go into the different files. Say for example, if I go into etc, and then I can see Hadoop. Is it small? I can make it little big. Okay, and ls. So these are the different files. We need to do the setting on core site, environmental shell. Okay, and then HDFS site.xml, a yarn environment map. Can you see here map reduction? Okay, all these things we need to install it. Okay, then they have only the configuration. We need to work on with that. So once if I go to if I want to start sorry, if I want to start my Hadoop, I need to go into sbin. Okay, where you can see start all.sh. Can you see here? Where? Here it is start all. I've already done it. And then if I give JPS, once I've just started and kept it, I'll be able to see in which port my name node runs, my data node runs, my resource manager runs. All right, can you see here? Main, the name node, the secondary name node, you remember? The data node, can you see the data node? And the resource manager and the node manager, which comes under yarn. All right, so this is how it works. And so today we have seen some introduction about, and there are different MapReduce inbuilt application. I'll be explaining about you how to work with what is the concepts of MapReduce maybe in tomorrow's class. All right, and then I can show you how in inbuilt functions are being. See here, I'll just copy this. Jesus. See, I'm giving to find the value of pi. Okay, I'm using an inbuilt function. Okay, so I'm pasting it. So Hadoop jar, I told it I will install inside this user local stellar Hadoop version share MapReduce and MapReduce. I have inbuilt function called pi function. I'm giving 16 and 100. So it takes mappers of 16 mappers. It will run and then execute it, and at the end you'll be able to find the result. This is an inbuilt function that is given. Okay, I show you that, and with that we'll wind it up. Can you see number of mappers are 16 samples per map, whatever value I've given into this, and then here it is running your Hadoop native libraries using your built-in Java functions. You can write it using Java or also using Python. Just running. Once it is run, you'll be able to find the answer. What is the value of pi? Maybe tomorrow I can show you what are the inbuilt functions available. See, it writes how many, and it starts a job. See, can you see the job tracker metric started? The job has been scheduled and it is running now. Usually it will be more faster. I don't know. This time it's a little slow because okay. At the end, you will get your results. Let me see. What is the value of pi that we need to get? Answer please. Pi. What is the answer of pi that we need to get it? Anyone? Answers on chat? What is the value of pi? 3.14. Thank you, Nitya ma'am. Let's check it out. Are we getting it here? 92/7. It's an inbuilt function. It works. See how much functionality, because how many mappers, how many reducers, how it merges. Okay, I'm just using an inbuilt function that is available here. Maybe at the end of it. Yeah, can you see? Can you see the answer? The estimated value of pi. So how many seconds it has taken, how many files it has encountered, because the file is onto HDFS. The map reduced how many mappers outputs. This is just an example to show you. So today we started with what is big data, how it is used in Yahoo, it's used in YouTube, in LinkedIn, and Facebook. All right, and then we started with the use of Hadoop and how Hadoop is been done. The logo, you remember, it's a yellow elephant, and then the entire framework of Hadoop of HDFS yarn, the MapReduce Hive, the drill, the mlib, then the pig and the Uzi, the zookeeper, and all the other components. And then how do you take a structured data and unstructured data, and how you process it. And then we focused onto the two components, HDFS and MapReduce, and how what is name node, what is the data node. Both comes under HDFS. Name node belongs to the master and data node belongs to the slave. And when you come into the MapReduce component of it, when you come to the MapReduce component of it, you have a job tracker and your task tracker. Job tracker is your master, and the next one is your slate. And we have seen a demo of using an inbuilt function, okay, of pi using MapReduce, and we'll explore more about MapReduce tomorrow. I think it's time. Thank you all for joining.
Yes, ma'am. Yes, ma'am. Thank you, ma'am. Thank you so much, ma'am. Ma'am, today we got a good startup for the big data.
The voice is not audible.
Session. I hope everyone.
Yes, ma'am.
Thank you, Doreen, ma'am. It's a wonderful session, ma'am. Actually, we got a good startup with the big data. You have given a clear idea about big data. Who doesn't know what is it? Okay. Thank you, ma'am. Thank you so much for your contribution. I hope it will be more interesting in forthcoming days. Thank you, ma'am.
Welcome, welcome all. Welcome, ma'am.
Thank you, ma'am. Thank you, ma'am.
Welcome.
Thank you, ma'am. Thank you.
Welcome.
Thank you,
Welcome.
ma'am.
Thank you, participants. So you can fill the
Dear,
which has been shared in
dear
your, ma'am. So if you didn't fill the feedback,